Hi everyone. As of now, we have completed hypothesis testing, and only few topics are left in statistics. So now we can complete even that covariance and correlation coefficient, Spearman rank correlation in this video. So what is a covariance? Covariance is, as per definition, measures the direction of the relationship between two variables. Is nothing but suppose a small example we can take x and y. These two are the variables. What is these variables? This is nothing but x is nothing but height and this is weight. So is there any relationship between the height and weight of the human beings? For any person, a person suppose is having 175 centimeters of height. So most probably actually 175 centimeters guy need to be 75 kgs, right? So in the same way, 165 kgs, 150, 165 centimeters of height, maybe 60 kgs. So if a x variable is increasing, if the y variable also increasing, so these both are in having the covariance in between the x and y. So for sure, height and weight, there is a covariance is there. That also and also positive covariance. Because what is the positive and negative covariance? Positive covariance is if one variable is increasing, another variable also increasing. Then we can say this is a positive covariance. Suppose the x variable is increasing, simultaneously this y variable is decreasing, variable y value is decreasing, then what happens? It is a negative covariance, we can say. Okay. If there is no relationship at all, there is no relationship, then what we can say? This is a zero covariance and also neutralities, no covariance at all. So this is called as a covariance. So height and weight is a positive correlation, covariance is having. Okay. Then what is the main difference between covariance and correlation? We can see later. But what is the formula for covariance? This is a formula for covariance. Covariance in between x and y. X is one variable, y is one variable. Summation of xi minus x bar. What is x bar? X bar is nothing but average of x, average of all x values, and y bar is nothing but average of all y values. Okay. So xi, each and every x value has to be subtracted from the mean, and y also same, and those things need to be summation, multiplication. Product has to be summation by n. N is nothing but sample value, total population value, if it is a population covariance formula. Okay. Then little difference between the sample covariance and population covariance. What is this? This is the n. Here it is n for population. Here in sample covariance, this is n minus 1. What is this n minus 1? This is called as a Bayesian correction. So because sample always what we do? Very less. From out of 100 or out of thousands, only 10 or 100 we can take a sample to calculate the covariance. Is the covariance is there or not? How much covariance is there? Right. At that time, we need to take n minus 1. This is called as a Bayesian correction. We can have another video also on Bayesian correction. As of now, you can remember, as for sample covariance, this is n minus 1. Population covariance, this is n. Okay. So here, the calculation also I have done. Hours score. Okay. So a student is how many hours is studying. Based on that, how much score he is getting, we can say. Okay. So if a person who is studying for 3 hours per day, he got a 70 score, 70 percentage of marks, suppose we can say. So 5 hours, 80, 2 hours, 60, 7 hours, 90, 4 hours, 75. By looking into this, some covariance is there, some relationship between the X and Y we can find out. Okay. So exactly how much covariance is there, we can see here. Okay. Total hours is this much, and total score, this is average, not total. It is average. Sorry. So xi minus x bar for each and every value we have calculated here, and y minus yi minus y bar, and product of two, the same, whatever that is in this formula is there, we are calculating here, right? And product is this much, and total is again summation is sigma. This is I have done, and n minus 1, as it is a sample, we have to go for this formula. N minus 1 is 4, so this is 21.5, 21.25. Okay, this is a covariance of 21.25. By looking into that, we can say it is a positive value or negative value. Absolutely, it is positive value. So it is a positive value. So we can say there is a covariance is there, and also that is a positive covariance. So X is increasing, Y also increasing. So it is 3, it is 70. If it is 5, it is 80. If it is 7, it is 90. Right? It is increasing only. So as it is increasing, we can say it is a positive covariance. But is it strong covariance or weak covariance? We can't say with the value of 21.25, because this value is purely based on these scores and these values only, it will be there, right? So is it strong or weak covariance is having? We can't say, right? So to know the is it strong or weak covariance, correlation coefficient came into the picture. We can see regarding the correlation, a small difference between the correlation. Yeah, see, this is also covariance. See here, by looking this images, what we can find here, this is a x-axis, this is a y-axis, right? If x-axis very high value of x, this is the very low value of y. Okay, so x value is decreasing for each and every dot, but y value is increasing. So this is, we can say it is a negative covariance, large negative covariance. It is in the same way, it is a large positive covariance, but it is a zero covariance. There is no relationship between x and y at all. Okay, this is a covariance. Then what is the correlation? Correlation coefficient is nothing but is it strong or weak, we can find. So in our covariance, how much value we got it? Nearly 20, some 23.25, I think, right? Yeah, 22 or 20, 21 or 23, we got it. Okay, whatever. Some value is there. But is it strong or weak? We can't say. But correlation, it is completely different. Correlation is from -1 to +1 only will be there. Either -1 to +1. It is ranges between the -1 to +1. 0 is no correlation at all. There is no relation at all for x and y variables. So -1 is as it is a very minimum value. If we got -1, it is a complete highest negative correlation. If we got +1, it is a highest positive correlation. If we got suppose 0.8 positive, so it is strong correlation, strong positive correlation, we can say. If it is -0.9, suppose, it is also very strong correlation, that is also negative. If it is a suppose 0.1 also there. Okay, 0.1 means There is a correlation is there, but very weak correlation, that is positive correlation we can say. So this is the main difference between the correlation and coefficient, coefficient and covariance. Okay. Yeah. Here see, the correlation coefficient is covariance divided by the product of the two variables standard deviations. That's it. It is a covariance formula only, right? Just see here, it's a covariance formula. What is missing here? By n. By n only it is missing here. But here, it is a standard deviation. Square root of summation of xi minus x bar whole square. So it is a standard deviation. Here also n is missing. Right. This is a standard deviation. This is a covariance. Anyhow, in denominators n and n will be cancelled. So finally, this is the formula. This is the correlation coefficient formula. If we calculate correlation coefficient, automatically it will come for any values from -1 to +1. Okay, that is a correlation coefficient. Yeah. Main differences between the covariance and correlation we can see. It shows the extent to which two variables are dependent on each other. Higher the number, higher dependency. Yes. Okay. It measures the strength of two variables considering other conditions are constant. All other conditions are constant. Both are how much strong correlation is having. That we can say with correlation. Right. It ranges -infinity to +infinity. There is no limit at all. Here range is -1 to +1 only will come. Okay. Minus or plus. Okay. It is affected by scale of the variables. It is not affected by the scale. Okay. So this is the main difference between the correlation and this thing. Yeah, it has definite units. Perfectly, units will be there, correlations. Divided by multiplied by the number of their units. Units, height also having the units and weight also having the units. So if height and weight both are having the units of length in centimeters and weight in kilograms, automatically those also, covariance also will have units. Okay. Centimeters by kilograms like that. But here, there will be no units at all. Because anyhow, it will come from -1 to +1. It is a coefficient. Okay. This is the main difference between the correlation and covariance. Yeah. Then the important thing is Spearman's rank correlation coefficient. Spearman's rank correlation coefficient. It is also correlation only, but rank correlation. So we are giving the importance to the ranks. This is the formula. Spearman's rank correlation is nothing but 1 minus 6 summation of di. What is the d? D is nothing but difference. Difference between the ranks. X rank and Y ranks we have to take. We can go for one example so that you can get a very clear idea. Di square by n into n minus n square minus 1. This n is nothing but the sample size. Okay. Number of observations we can say it is sample size. Okay. Spearman's rank correlation. Di is difference between the two ranks of each observation. Okay. Let us go for example so that you can get an idea. So these are the marks of English and mathematics of different students. Okay, in English, 56 marks and maths, 66 marks. These are the marks 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Exactly. Yeah. These 10 people got, these are the scores. So what to do? How to calculate the Spearman's rank correlation for them? As we are saying, it is a rank correlation coefficient. First, what to do? These are the marks as it is we have copied here. And we are giving the ranks to those marks. But which is the highest marks here for English marks? English ranking we are giving here. Okay. 80 is the highest marks. Is it correct? 80 is the highest marks, right? So 80 is having the first rank. See here. Then what is the second rank? 76 is the second rank. Yes, second rank. After that, 71 has to get the third rank. In between 70, this fourth rank given means, is there anything in between 76 and 71? Yeah, it is there. Yeah, 75. 75 is having the third rank. 71 is having the fourth rank. Like that, each and every marks we have given the ranks. Okay. Then in the same way for mathematics ranks. Okay. Where is the first rank? First rank, the same person got, that is 77 marks. It is the first rank. Second rank is deferred here and there because 70 marks is second rank here. Okay, here he got a fourth rank because 66 marks is fourth rank means what is the third rank? Third rank, 66, 67 marks is there, third rank, so third rank. Like that, we have to assign the ranks to those scores. After assigning these ranks, this is no use at all. Just we are not at all considering these things. Just to have taken ranks from those scores. Then what to do? D is nothing but difference. Difference between the ranks. 9 minus 4, it is 5. Okay. 3 minus 2, it is 1. Then again, what to do? D square. Square of. Okay. Then what is the next step? Difference is nothing but where difference between the ranks and D square, difference is square. When calculating summation of DI square, all the differences squares we have added. This sum is nothing but 54. Okay. So just we can go to the formula so that we can get it. So Spearman rank correlation is 1 minus 6 summation of DI square. Okay. N into N square minus 1. 6 into 54, which we have calculated. And N is nothing but 10. 10 square minus 1, that is 990. We will get. This is a simple calculation we have done. This is the 0.67. By looking into that, what we can find? We have positive correlation, positive rank correlation also positive, and also as it is a 0.67, it is also ranges from -1 to +1. Same. Okay. It is not 1, it is not 0. So, okay. Medium correlation is there, that is positive. Okay. You understood, I think, right? Yeah. The Spearman rank correlation coefficient. Right? RS means Spearman rank correlation. Can take values from +1 to -1. ARS of +1 indicates that perfect association ranks of rank correlations of 0 indicates no association between ranks. Okay. Indicates a perfect negative. If it is a -1, it is a perfect negative association. Okay. The closer to rank correlation is closer to 0, what will happen? Spearman's rank correlation 0 means very weak association. Here we can say, is it weak or strong? It is not weak, not strong. It is medium correlation. Medium correlation is there in between the two mathematics and English marks. Okay. Thank you. These are the topics of the statistics. Most of the topics we covered, but only very less topics we left out. That is t-test and z-test and chi-square test and ANOVA test. These also I am going to make a videos. As of now, these are very much important, and also we can understand. This is enough for going forward in data science. This statistical information is. Okay. Thank you.